Dear teachers and classmates, I'm Wang Jieyang. The topic of the publication is a novel chaotic system with 11 piecewise linear functions and its analog circuit implementation. I will report from the following four aspects. Chaos is a nonlinear phenomenon widely existing in nature, and it is a basic form of motion. The motion model of a dynamic system depends on two factors, one of which is the dynamic equation of system, and the other is the initial conditions of system. For a deterministic system, when the system equation and initial conditions are determined, the result is determined. That is, the deterministic equation gets a defined solution. But in a chaotic system, even if the equation and initial conditions are determined, an uncertain solution will still be obtained. In the chaotic system, three main rules are leading to choice, namely the period doubling bifurcation rule, the PM-type intermittent rule, and the Passive period rule. The way to enter choice through PM intermittent rules is relatively rare compared to the other two, and it has a higher research value. The PM-type intermittent rule was proposed by French scientists Y. Fomin and P. Manolive, and it is also called the intermittent choice rule. The generation mechanism of PM-type intermittent rules is closely related to the tangential bifurcation. This way occurs before the starting point of the tangential bifurcation, and the performance is that the periodic state and the chaotic state alternately appear with parameter changes. When one of the parameters of the system is lower than a certain value, the system exhibits regular, periodic motion. When the parameters gradually change in a certain direction along the number x, the system exhibits an achromatic periodic motion of a long time. In the process of gradual change, the system have a brief chaotic behavior, and then it becomes periodic motion. This method is repeated continuously. With the change of parameters, this sudden phenomenon becomes more and more frequent, and the approximate periodic motion becomes shorter and shorter. Finally, the system enters a completely chaotic state. Piecewise linear function is a kind of nonlinear function, which is usually used to make multi-score chaotic systems and has important application value. According to the different values of the slope of the function, piecewise linear functions can be divided to four categories. By changing a parameter in the function, the number of wings of the multi-score chaotic state can be flexibly changed. In this paper, by adding 11 piecewise linear functions to the chaotic system to increase the complexity. A new four-dimensional chaotic system with complex dynamics is abundant. The stability of four-dimensional chaotic system is analyzed, and the results show that it is in a stable state, and the attractor of the system is hidden. The complex dynamics and the balance characteristics of the new system make it have a high application potential in military information transmission and confidential communication. In this paper, the structure of new 11 piecewise linear functions and the attractor state of the system are introduced in the first part, and the equilibrium point and stability analysis of new chaotic system are described in the second part. By using a bifurcation diagram, linear exponential spectrum, and a test method, the domestic characteristics of this system are analyzed in the third part. The analog secret corresponding to new four-dimensional chaotic system is designed through Key's law and secret principle in the fourth part. The summary of the research results of this paper are presented in the fifth section. A new four-dimensional chaotic system with 11 piecewise linear functions can be expressed as this. Among them, H represents an 11 piecewise linear function, and piecewise function Hx is an odd function, which is usually used to generate an even number of multi-scalar functions. In this paper, it is used to construct a new chaotic system. The construction method greatly increased the complexity of the chaotic system. The corresponding mathematical expression is shown in Formulate 2, and the corresponding functions imagined is shown in Figure 1. In Figure 1, the turning point value is EI. The width of the linear interval is WI. The slope of each interval is I, and the height of each turning point is equal. From this, the relationship between the width WI of each interval and the first turning point EI1 can be expressed as this. In Formula 3, I are 0, 1, 2. The slope mi of each interval and the first turning point value E1 are incorporated into formula, and the calculation formula for turning point En can be obtained as this. Expand it to the get formula 5. So the specific expression of the 11 piecewise linear functions can be expressed as this. When the system parameters take A is 4.5, B is 1.6, C is 9.5, D is 9, E is 6.7, H is 8.1. I'm 0, I'm 2, I'm 4 are all 0.5. ME and M3, M5 are 0.3. The first turning point value E1 is 0.4. The intensal value is 0.1. When the step length is 0.01 second, the L exponents of the system is this, and the system first diagram is shown in figure 2. The time domain diagram of the system is shown in figure 3. Balance point analysis of system. The divergence of the four-dimensional chaotic system is this. When here, the system is dissipative and the volume of system is 0. When T approaches infinity, like the parameters A is 4.5, B is 1.6, C is 19.5, D is 9, E is 6.7, H is 8.1. M0, M2, M4 are full 0.5. ME, M3, M4, 5 are 0.3. E1 is 0.4. When the intensal value is 0.1, the divergence is less than 0. The system at this time is dissipative and has the conditions to produce choice, like the differential equations of system are equal to 0. That is, when the system equation takes this, the equilibrium point of the system can be obtained. This. It can be easily found that the equilibrium point of the system is P. L the system at the point P, and J matrix of the system is this. Among them, expand Px to get formula 10, like this. By analyzing the J matrix, the characteristics polynomial of the system can be expressed as this. According to the R stability equation, the system is stable under the following conditions. Putting An into formula 12 to calculate in turn show that the system is stable according to the stability judgment. Therefore, all actuators in the system are hidden attractors. Dynamics analysis of system. The diffraction graph and L exponent spectrum are important indicators to determine the state of system. To obtain more accurate parameter values when the system enters choice, the 10-test method is used for system analysis. This test method can accurately determine the parameter value when the system enters choice. Like the system parameters A is this, B, C, D, E, H, and M0 to 4 is 0.5. M1 and 3, 5 are 0.3. E1 is 0.4. The initial value is 0.1. When the step length is 0.01 second, the diffraction diagram and L index structure obtained according to the change of Z are shown in Figure 4. According to Figure 4, as parameter C decreases from 21, the system begins to produce a transient state of choice. When the parameter value is C, the system enters choice for the first time. The L exponent is this, and the duration gradually becomes longer, and finally it turns a continuous choice state. When C is this, the system begins to show a reverse pivot doubling bifurcation. At this time, the L exponent is this, and the system gradually enters a new choice state. The 10-test chart when the system enters choice and pure state for the first time is shown in Figure 4. Like the system parameters, A is this, B is this, C is this, E is this, H is this. I'm 0, 2, 4 is 0.5. I'm 1 and 3, 5 is 0.3. U1 is 0.4. The internal value is 0.1. The step size is 0.01 second, and D. The Biraction graph and L index spectrum of the system are shown in Figure 6. And the Figure 7 is the 10-test chart when the system enters the choice state and the periodic state for the first time under different values of the parameter D. With the increase of D, when D is this, the system enters a choice state. At this time, the L index of system is this. When D, the system behaves as a periodic state when the D is 8.623. The system is in the periodic window, and the L index of the is at that time is this. When D is 9.7119, the system enters a periodic state. At this time, the L exponent is this. Analog secret design of system. In order to perfect the theory of system, an analog secret corresponding to the new system shown in Formula 13 is designed. The analog secret is composed of one arithmetic secret and an 11 piecewise linear function secret. The complete secret consists of resistors, capacitors, multipliers, and operational amplifiers. Dimension Formula 13 to obtain the equation system shown in Formula 14. The first and second differential equations in equation system and are coupled with each other, corresponding to the two sets of secret in Figure 8, A and B. The piecewise linear functions is added in the third differential equations. Among them, V x to V are the four secret variables of the simulate secret. The G1 to 6 are the amplification coefficients of the multifier, and V represents the constant term. According to the logical relation shown in Formula 14, combined with K law and the secret principle, the analog secret corresponding to system 13 can be obtained. So we can have a conclusion in this paper by introducing 11 piecewise linear functions to the choice system. A new four dimensional chaotic system with complex diametric behavior is proposed. Methods such as bifraction diagram, the L spectral phase diagram, and t-test are used to analyze the system. Numerical simulation results shows that due to the introduction of 11 piecewise linear functions, the system has hidden attractors and complex dynamics. For example, when some parameters are fixed, when the parameter C becomes smaller, the system shows obvious impulse. The chaotic state of the system appears more and more frequently and lasts longer and longer until it finally enters the chaotic zone completely. Finally, the analog secret diagram corresponding to the system is designed using the circuit principle, which provides a complete zero-chaotic basis for scholars to study the system. The complex systematics of the system provide a good prospect for its practical application. That's all. Thank you.